We are into our final voice signaling protocol, SIP, the Session Initiation Protocol, which many believe to be the protocol of the future, the protocol that will be used across the board for all voice signaling, and I happen to be part of that many. So let's dig into SIP and find out what the big deal is about this protocol. As we talk about SIP, I would like to start things off the same way I've started off with MGCP and H323, just with what SIP is all about. Give me a definition, give me a reason why I would use SIP over the other two protocols, and what's its point. Well, I'll start off with a commonality. SIP is really geared around the same functions as H323 and MGCP in that it's about voice over IP session management. It's about getting voice sessions going between different clients, but it's much bigger than that. SIP is defined as one module of a voice over IP solution, meaning it's not a complete solution like H323. H323 is a protocol suite. It's got all kinds of sub-protocols that are integrated into this protocol suite. Its goal is to be the package that starts and ends voice, video, and data session. It includes the codecs, it includes the video codecs, it includes the audio, it includes data sharing, session startup, feature negotiation, I mean everything. Everything is in H323. And in a way that's good because you got it all in one protocol, but in a way that's bad because you got your protocol suite and that's it. I mean, it doesn't go beyond the functionalities of where that protocol stands today unless you start upgrading the whole protocol suite, and then you got problems with everybody running the same version of H323 and all that kind of stuff. So when they designed SIP, which stands for the Session Initiation Protocol, their goal was to simplify it, in that SIP's goal is not to start audio calls and include codecs and video call codecs and data sharing. Its goal is just session management. It's creating, modifying, and terminating sessions. Now notice there's no little, descriptor in there. It's not like voice over IP or video or data. It's just sessions generically. Now you can apply SIP to voice over IP so that it starts voice sessions, but you can also apply it to video and have it manage sessions for data sharing and all kinds of stuff. So the possibilities are endless because I'm trying to think of a word picture that can convey this, but you think of H323 as just this closed box, right? H323, the little bow is on top, right? That was my bow that turned into antennas. But you've got your little sorry guys, you see the bow, right? It's a bow. It's tied. It's a package of protocol things that is locked. In that box, it contains everything that H323 can do from 1985 all the way through 2009 through the great beyond. It's a package. It does what it does, and it's starting to get dusty and old, but you're not really going to see that package being upgraded. Whereas SIP is kind of this there's my word picture that I was looking for. SIP is kind of like, have you played with the Microsoft Management Console, the MMC? If you've got some Windows experience, if you're running Windows Vista or XP or something, and you haven't seen MMC, go ahead and click on Start. Matter of fact, why don't I do it? Start, Run. Cursed Vista doesn't have a run. Start. If you got Windows XP, you gotta run. And this is the MMC. Start, run, and you type in MMC, Microsoft Management Console. What is it? Nothing. It's nothing and it's everything. It's a shell, right? And you can go in here and you can say, well, I want to add and remove a snap-in, and that's where you can go in. And you choose your snap-in and say, well, I want to manage the disks of my computer, and I want to do an IPsec monitor and monitor my IP security and event viewer, and you can just keep adding all of these different pieces. And I think I just killed my computer. Oh, there we go. To the local computer, and I click on OK, and now I've got all of these tools that I can use to manage my computer. That I can look at the disks and check out the event viewer and all that kind of stuff. Isn't this amazing? My Windows Vista machine, you see how long that took to load? This machine is like dual core, 4 gigs of RAM, and it's just dying. So anyway, enough about Windows Vista. The point is that the Microsoft Management Console is this. It's nothing and it's everything at the same time. It's the shell that we put all these new little plugins in. And in the same way, SIP is kind of like just a session management utility. It's nothing and it's everything at the same time. It allows us to start voice over IP and video over IP and data sharing and all kinds of stuff, but it's expandable because people can write little plugins and add-ons, and it's not a box where it's just everything's inside and included. It's an open standard where people can just write all these different plugins so that SIP can be managing a voice over IP call, as well as it could be managing, I don't know, a video game arcade session where two video games are speaking together and starting. There you go. Here's one where SIP is used. You're sitting in one of the online shooter games. My I don't play games anymore, but my history goes back into the Half-Life, Counter-Strike days where you talk to people as you shoot them and you say, hi, gotcha, and stuff like that. Well, you got headsets on and you're starting these audio sessions with people all over the world. Well, you got your Counter-Strike plugin for SIP, and SIP is managing all of those sessions. It just manages sessions. I think I've hammered that point home, right? You got it? So it's expandable for the future. So, session management includes 4 tasks. Let me hit these and then we'll move on from the basics of SIP. It locates users, meaning it translates a SIP address to an IP address to find out where that user is. Now, a SIP address can be a phone number. It can be an email address that, we could say, I want to call jeremy@home.com. That actually used to be my email address before the at-home network went away. So I want to call jeremy@home.com, and that will translate that to an actual IP address where my instant messenger or IP phone starts ringing. It negotiates capabilities and features, very similar to H.245 of the H323 protocol suite, so it still does feature negotiation. It can modify the parameters during a call, so you change audio codecs, you put somebody on hold, conference calls, those kind of things. SIP can handle that. And it handles the setup and teardown of all users. So when you bring somebody into a call or end a call, SIP can handle that. One of the reasons SIP is becoming so popular is because it borrows many familiar internet standards. It's created by the same organization that created HTTP, DNS, and all those kind of standards, so SIP integrates seamlessly with them. For example, it integrates with DNS to look up many of the SIP phone numbers and addresses and contact SIP servers. It integrates with HTTP. When you actually take this example, you open a web browser, right? And you type in www.foogle.com. You mistype Google. Well, you're gonna get back. Right? You know what? Even better. How about we go to if we were to say google.com/whoops. .text or something like that. Now, I don't know. I haven't tested that, but what kind of error message are you going to get when you type that in, assuming whoops.text doesn't exist? Well, you're going to get back, HTTP will send you a 404 error, a client error where you've mistyped something, if you type foogle.com or something like that, where it's saying you must have mistyped something because that doesn't exist. Well, in the same way, if you dial a phone number that doesn't exist and you're doing debug messages, you'll see a 404 error come back, meaning, client misdialed, client error, that kind of thing. The error codes are the same, the success messages are the same as HTTP. So when you're starting to learn SIP, if you're familiar with some of the other standards that are out there, it's going to be like, I've seen that before. That's cool. I don't really have to relearn everything. Or you remember when we did the debugs on H323 and you see the messages encoded and it's just like blah, 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 all this junk on the screen where you have to pull out your reference books and start looking things up. Well, SIP is all clear text, very easy to work with. It uses the Session Description Protocol, SDP, to exchange capabilities, and that is very similar to H245. So where H323 has H245 to exchange capabilities, SIP has SDP. One of the key features that does not exist in MGCP or H323 is the concept of presence. This is a nice concept that allows your phone system and video system and whatever systems you integrate using SIP to be very similar to instant messengers. When you're sitting in like MSN Messenger, and you see the little icon next to people. I don't know what it looks like, but it's like I'm here, or I'm available. And then you see like the next little icon says, oh well, this person has been away, because they're away. They haven't moved their mouse for 15 minutes or so, and this person is not available, whatever. You get the little icons in the instant messenger. Well, you got the same thing for your phone system, to where you could, and I'm using phone system because of course this is a voice over IP course, but you can tie this into any application you want, to where you can actually look and say, oh well, this person's on the phone. You can see that from their phone, kind of similar to the way receptionist equipment is, where you've got the hard lines and you can tell what users are on their phone, or this person's away from their phone, or doing whatever, and you can choose what people can see, what status messages they can allow, and all that kind of stuff. So that's a cool key feature. SIP will win. It's quickly moving to own the industry. You know how you talk about TCP/IP, and then if you're presenting that or talking to somebody about it that's never heard of it, you might say, oh well, we used to have these things like IPX, SPX, and NetBEUI, and DECnet, and all these protocols that just aren't used anymore because TCP/IP rules the world. Well, someday people will talk about H323 and MGCP as those kind of things. It's like, oh yeah, we used to have those protocols, but SIP now rules the world on everything. It's just, and I'll talk more about this later, it's not done yet. It's not ready. It's kind of like the car industry. If you go buy a car, you know someday, right? Well, you hope, but someday electric cars are going to rule the world, or some kind of alternate emissions, because we have a limited oil supply. Eventually, the world will run out of oil. Period. It's limited, so we have to have a new system. And electric cars will end up winning, but or something like them, but it's just not there yet because the development isn't there. They're still kind of buggy. They're expensive. There's a lot of reasons why that, and SIP's the same way. Microsoft, their voice over IP solution is completely SIP based, and they have quickly, very quickly, quicker than most people thought, moved into the competitive offering of voice over IP solutions, to where they're now almost a competitor to Cisco. You can buy a Microsoft voice over IP or Cisco voice over IP. Their solution is entirely SIP based. Avaya, very, very SIP based. Just about every vendor is going with SIP as their protocol. I'll tell you in a minute why Cisco hasn't fully jumped on the SIP bandwagon. But for example, these are just examples of how SIP is moving to own the industry. They're already designing hospital equipment to become SIP aware. So for instance, you could have a heart monitor that sends an instant message or a text message or a phone call to a nurse saying, hey, the patient in such and such building is having heart issues. It's not a proprietary system. It's all integrated with SIP, to where your phone doesn't have to be like a hospital phone to receive messages from this heart monitor. It's all just a standard-based SIP awareness. ITSP, Internet Telephony Service Providers, are using SIP as standard, to where I never remember what we talked about. I think we talked about ITSPs. ITSP, Internet Telephony Service Providers, are what you can use to run voice over IP essentially to the PSTN. They are a new next generation PSTN carrier that allows you to run voice over IP in your network, and you send the call out of your network as voice over IP. Much more efficient on bandwidth, much cheaper. They end up converting to a PSTN line if that's what needs to be done, or a POTS line. For example, Vonage, AT&T, they are completely using SIP everywhere as their standard for operating this. So with all that definition in place, why would you do it? What would be the point of running SIP in a Cisco network? Well, first and foremost, you're integrating with other phone systems via SIP trunks. For example, you might have an organization running Cisco Call Manager, and you acquire an organization that is running a voice over IP system powered by Avaya or some other vendor. Can't believe that vendor made its way onto my slide. And you need to run a trunk over to Avaya. Well, Avaya speaks SIP. That's their language that they use. And I'll talk more about that when I bring up my cookie tray down at the bottom. But if you need to trunk from your voice over IP network so you can place calls using voice over IP to the Avaya phones, SIP is your guy. That's going to be how you do it. Maybe you want multimedia application integration, like you want instant messengers to be able to call IP phones and be able to call cell phones and all this kind of stuff. SIP is the ultimate multimedia integration because it's not designed just for voice over IP. It works across the board. Cisco MSN Messenger, how about Microsoft MSN Messenger, supports SIP natively. So if you want to integrate with that, and Cisco's already creating and has created instant messenger solutions that integrate right with their voice over IP network using SIP. They support presence. That's another reason you would do it, to be able to see the status. You could open an instant messenger client and see the status of, is this person on the phone? Are they away from their phone? Do they have do not disturb hit on their phone so it goes directly to voicemail? All of that is able to be seen using presence. You want easier troubleshooting. Easier troubleshooting because everything in SIP is clear text. I'm going to show you some debugs, and it's very straight up. You'll be able to see SIP messaging going back and forth. It's invite, ringing. It's very easy to understand, very easy to troubleshoot. And then finally, supporting third-party phones on a Cisco Call Manager network. In Call Manager 6.x, not 4.x, you have the ability to support third-party phones. I could bring an Avaya phone into my Cisco network and let the Cisco Call Manager run it to where it gets its dial tone, its features, everything from Cisco Call Manager. Now, with that being said, that is a perfect segue into my little half-baked cookie slide down here. I always talk about SIP as it is still a half-baked cookie and will be for some time to come. What do I mean by that? Well, SIP is just, it's not done. It's done. I'm schizophrenic, right? I debate myself. It is done, but it's not done. It's got this signaling standard that's set up, but it's not a signaling standard that's supported across the board. Meaning, Avaya's got their own way of handling some things for their phones. Cisco has their own way of handling some things for their phones. Everybody's got their own way to handle certain features and capabilities and all this kind of stuff, and they'll always have their own thing. I mean, Avaya is probably going to come up with, hey, buy an Avaya phone system because our phones make coffee too. You can put a cup up to their phone and get a little espresso out of it or something, and that's all triggered via SIP. I mean, they're going to have some proprietary feature that you bring their phone over to the Cisco network, and the coffee making feature doesn't work. You call up Avaya, they say, "Oh, I'm sorry, that's an Avaya only solution. You got to get Cisco out of there." Or Cisco does the same thing. So the point is that vendors all have their own way of doing certain things, and SIP does not have signaling methods that handle all of those different features as of yet, and it probably won't for quite some time to come, if ever. I mean, here's the scoop. I mean, people look at Cisco and they go, "Well, okay, Cisco Call Manager uses what protocol to handle its IP phones? Skinny, right? Skinny is Cisco proprietary. You only use it to run Cisco phones." And there's no question with that. People are like, "Oh, well, that makes sense." And they say, "Well, Cisco, why didn't you use SIP to run your phone? Why didn't you use an industry standard way?" And Cisco's response is, "Well, we can, but SIP doesn't do everything that we need." For example, you can actually, I feel like I'm just vague right now. Let me get specific. You can get a 7960 IP phone, and you can go on Cisco's website, and it comes with a Skinny image, meaning this uses Skinny to communicate with the call manager. I can go on Cisco's website and download firmware for this phone that converts it to a SIP phone. Now, what does that let me do? Well, it lets me use an industry standard protocol, not a proprietary one, to manage this phone. But right on Cisco's website, they will tell you, if you use SIP to run this phone, you will not get all the capabilities. There will be some capabilities that's not supported. So, why would you use SIP to run a Cisco IP phone? Well, maybe you want to take that Cisco phone over to the Avaya network and let it work on the Avaya call system. I don't know what Avaya's call manager-like product is, but if we wanted our Cisco phone to work over there, we could use the SIP image. But in the same sense, if we took Avaya's phones, which do run SIP, over to the call manager network, they wouldn't work fully either, even though Call Manager 6.x can support SIP to an end phone. The reason why is Avaya has written their own little proprietary plugins for SIP to make certain features of their phone work. So you're not going to get a truly native solution. See, this is what I do. I just draw arrows. Let me just draw a few more arrows here. There's not enough of them on the screen. So the point is that SIP doesn't do everything, and I don't think it ever will. Frankly, I don't think it ever will be a complete solution, because Avaya is always going to come up with some feature that they don't want Cisco to support. And Cisco is going to come up with some feature they don't want Avaya to support. They don't just want to say, well, we've got coffee makers for our phones. Here, Cisco, here's how you make coffee makers for your phones, or whatever cool feature comes out. A thumbprint scanner to use the phone. Who knows what? There's always going to be something that's cool that every vendor wants to covet and say, this is ours. We're not letting this out. So they're going to use their own proprietary plugins. Now, in my opinion, I think Skinny will eventually die. I think Skinny will go away, and Cisco will use SIP natively for their phone, and Skinny will go away. But they're still going to have their own little proprietary plugins for SIP. Remember, SIP, I have talked way too much on this. But forgive me, but I really want to convey this point. SIP is just a signaling protocol. You can have it link into whatever you want. So if Cisco wants to write their own little proprietary plugin, or Avaya wants to, they already have a bunch of them, then they can, and SIP can work for that, but it's only going to work for that specific vendor. Whew, man, I feel like that slide just sucked me in. I couldn't stop talking about it. So let's leave it behind. SIP components. What makes a SIP network work? Well, all of the devices that make phone calls are considered user agents. There's clients and there's servers. The clients are the one making a call. So for example, I have a user agent client over here making a call to another phone, which acts as the user agent server. It's the one receiving the call and handling the call like a server does. Now, does that mean that this phone can't place calls? No, not at all. A user agent typically is both a client and a server. Doesn't have to be, but usually is. And if this one makes a call to this one, then it becomes the client and the other one becomes the server. So you always see the user agent client and server concept in SIP. Then you have a host of servers down here. Proxy server, redirect server, registrar server, location, and presence servers. These are all industry standard specifications for servers that run on the SIP network. Now, the specifications doesn't say they have to be separate servers. These could all be functions on one servers, but they're distinct functions in the SIP network. For example, the proxy server. The proxy server is the initial point of contact for the user agent. When I pick up a phone and place a call, it's going to go to the proxy server, which is essentially the Cisco call manager, that is the proxy to help it find where it's going to get that call. It's kind of like, when you're lost on the road and you pull over for direction, the person that you're asking for directions is the proxy. They are the one to proxy you to your destination. So that's kind of what the call manager acts as, the initial point of contact to help it reach its endpoint. The redirect server. The redirect server finds a location of the endpoint, and you can see how easily this is combined with a proxy server. The proxy server says, okay, let me take responsibility for that request. The redirect server says, okay, let me find that location and then redirect you, send you on your way to whatever destination you're going to, this phone over here. The registrar server is the one that registers the endpoint into a database. So when this phone comes and says, hey, I'm extension 1000. That comes to the registrar server and says, oh, great, let me register you, and I will put you into, you can see they all tie together, to the location server. The location server is the one that is the database. It holds the database of all the user agents. So, typical request comes to the proxy server. Proxy server says, let me look in the location server database of where you're going. Okay, let me redirect you, redirect server, to another phone, and the call is placed. So, presence server down here tracks the status of the user agents. Now, Cisco does sell a separate server for this. It is Cisco Presence Server, and that allows you to maintain essentially a database of statuses of all of the user agents in your network. Now, with SIP, remember, user agents go beyond phones. You're talking instant messengers, you're talking computers, soft phones, you're talking television sets can be user agents. Just about anything can run the SIP protocol nowadays. Now this is the part I love, the SIP messages. When we were looking in the previous nuggets at H323, MGCP, you kind of have these cryptic messages and you're like, oh yeah, we've got the H225 setup message which is encoded in all this kind of way. With SIP, everything is so clear text. You actually have different styles of messages. You have the methods and you have the responses. So the methods are something that takes action, like I want to register, I want to invite. A response is a response to one of those methods. Bleh. So when I send an invite message to another phone and say, hey, I'd like to make a call with you, I might get a response message saying success, 200 coming back saying you are good. Or maybe I get a response from the server that is a redirect message saying, 300, go this way to get to that phone. There's all kinds of different responses that I can get to my methods. So the methods are so clear text, it just makes sense. Register, registers a phone. Invite, invites another phone into a call. Ack, acknowledges some kind of message. Cancel says I'm done, cancel that request. Options is to change the options during the call, like maybe we change the codec or the bandwidth usage. Bye, I'm not even going to explain it. Responses. You can see responses, these are the same as HTTP. You have like informational responses. For example, 100 is trying. Like when I send an invite message, I might get a trying, like the phone is ringing. Trying says I'm trying to connect, and then you another information like it's 180. 180 is ringing. That tells me the phone on the other end is ringing. Or 181, call is being forwarded. You don't need to know all the specifics of these, but my point is there's all kinds of different codes that tells the other one what's going on. There's only one success message, and that's code 200. Redirect messages sending you somewhere else. Client error codes like a 404 error is clients not found. A 401 error is you're unauthorized. You can't access that client. There's some kind of restriction. Server error is something bad has happened with the server, like the server is having a problem, like a 500 internal server error, or server timeout. The server did not respond in time. And then there's global failure. It doesn't sound as bad as it's not like the world is burning. It's everything's down. That just means like all the extensions for that was busy. Like maybe there's 50 different extensions for 500, but all of them were on the line and they couldn't answer or something like that. So these are all the clear text messages that you would see, and you see them just like this if you do a debug. Well, now let's take a look at the call flow. Notice that I have Call Manager 5x or 6x over here because that is the only version of Call Manager that supports SIP to the end phone. In Call Manager 4x, it can support a SIP trunk to a gateway or to like an Avaya system, but it doesn't support controlling the phones directly. So if I'm using SIP from the end device, and this phone maybe wants to call off to the PSTN, it's going to send an invite message, picks up the phone, dials a number, sends an invite message to the call manager saying, hey, I'd like to call to the PSTN. The call manager sends that invite message to the gateway, and we're assuming everything is SIP here, not H323. The gateway responds and says, oh, okay, well, I am trying. Message 100, trying. So at that point, it's actually dialing out to the PSTN, trying to see what's going on and get a phone to ring. As it gets a ringing signal, it will send back session progress messages. That's type 183. And inside of there will also be the session description protocol, which is exchanging all the features, negotiating the codecs, and all that kind of thing as the ringing signal is occurring. Once the phone out here answers, somebody picks up the phone, the gateway will send a message to the call manager. The call manager is kind of the proxy here. It'll send a 200 message saying success. We have a success message. Okay. It relays that success message over here to the IP phone, and at that point the RTP stream flows from the IP phone to the analog device out here through the gateway. So you've got RTP happening. Now once the RTP stream is done, one of these phones hang up. This will send a bye message, and I'm getting crazy with my arrows here, but the gateway or the gateway only communicates directly with the call manager. The call manager is the proxy. It says, okay, bye, sends the bye message here, and then it confirms back. We get some errors, bye, bye. It's like this bye flurry, bye, bye, bye. Everybody's saying bye, and you get the okay, call's done, hung up. As we now move into the configuration, I have 3 different scenarios to work through with you. And configure SIP, we'll do some debugs, we'll watch it happen. It's actually really easy. We're going to configure SIP dial peers to start off, then configure the gateway as a user agent, and then permit call hairpinning, kind of an IP to IP gateway between H323 and SIP conversations. So we'll start off with the dial peers. Here's our mini scenario. I'll just draw a slight network diagram. Not too much different from the other configurations we've done with H323 and MGCP. I've got Cisco Call Manager sitting on the network. And we already have those dial peers configured from the previous nuggets. Communicating with a voice gateway, and this voice gateway is currently connected to an FXS analog phone. I also have IP phones sitting on the network that are making phone calls and so on. And as of right now, these are skinny. I'm not running SIP to the IP phones because I want to allow this to be our SIP device. So essentially, the call manager is going to be a proxy between the skinny IP phone and the SIP device over here. What I'm going to do is I'm going to configure this gateway to use SIP when communicating with the call manager. We'll set up a SIP dial peer. And then I'm going to use call manager. I'm going to configure call manager with a SIP trunk back to the gateway so it can use that. So let's start off with the gateway. I'm going to bring up, let me clear off all this old configuration from the previous nuggets. Bring up this gateway, and actually I'll start off with a command I think was just typed in there. Show dial peer voice summary. Now I already have the dial peer configured for call manager. This is the one we set up in the H323 nugget to get this gateway communicating with the call manager. So I'm going to go under that and modify that to be a SIP dial peer. It's, as I mentioned, really easy. I'll do dial peer voice 2000 to get under there. It's already a voice over IP dial peer, so I don't have to include that. And I'm going to type in session, and instead of session target, like IP address, I'm going to say session protocol, and I'm going to use SIP. SIP version 2. That's the IETF industry standard SIP protocol that I can use to communicate with the call manager. That's it. On the gateway, it's now going to start using SIP when it's communicating with the call manager or whenever somebody dials to ... Now I need to make the call manager aware of this, so I'm going to bring it into the picture. There we go. And instead of configuring a gateway, call manager doesn't communicate through SIP gateways, it communicates through SIP trunks. It's considered a trunk to another SIP device. So I click on trunk, and I'll say I've got to add a new trunk here. Trunk type will be SIP. Device protocol, SIP of course. Click next. Now it comes up and says, what is the device name? And I'll just put, you don't have to, but I'll put the IP address. Well, that's it right there. 172.30.4.3. That's the IP address of my gateway. A description, I'll just say SIP trunk to gateway FXS port. And on that gateway, I still have the FXS port assigned this phone number, 1800. So that'll play into our scheme. That'll be the phone number I dial to access the FXS port on there. So I'm going to say, let's just put extension 1800. So I'm reminded of that. Device pool, call manager supporting it. And I scroll down here to the bottom, and it says SIP information. We have destination address. Well, here I'm going to put that 172.30.4.3 as well. It's the IP address. That doesn't have to be the same here. I could put a name like gateway or something like that instead of 172.30.4.3. I just like using IP addresses everywhere, but you can put a name. This is the actual address it's using to communicate with it. And then down here I say what security profile. You can set up different SIP security profiles, so you can have encrypted SIP messages back and forth. And I have my SIP profile. These are just SIP configuration profiles call manager uses. I'll just use the standard one that's built in and click on save. It says click reset to have it take effect. I will do that and reset the SIP connection. So I now have a SIP trunk on the call manager 6.x config. Now I need to tell it when it's going to use that SIP trunk. I'll go to the call routing and create a route pattern and say whenever I have an IP phone, dial extension 1800. I want you to send it to that SIP trunk. And no, I don't want to provide outside dial tone there. So 1800 goes to the SIP trunk. Click on save. Mentions my authorization code. I don't have any typed in. That's fine. Click on OK, and we are good to go. I now have configured a SIP dial peer from the gateway to the call manager and a SIP trunk from the call manager to the gateway. So now I should be able to dial either way. Let me pull up the gateway. I'm actually just going to reach over and I'll dial from the IP phone. Well, the phone rings, but you didn't see much action. Let's do a debug. I was thinking, I was like, how can I show this? I'm going to do a debug. Let's do a debug CC. Let's call control SIP, and we'll do the messages to watch the SIP messages taking place. So let me let's see which direction I'm going to go. Let's go ahead and do the same direction. I'll just hit redial on the IP phone. There we go. So right now, let me just turn off the ringer so I can talk for a little bit. Right now, I just had a plethora of events come across. You can see, right after I turned on the debug, I made the call from the gateway, and this event is an invite. It says, received an invite message to the SIP address. Look at this. Isn't this addressing awesome? SIP address 1800 at 172.34.3. So that tells you right there, phone number that was dialed, IP address that was receiving the call, and there's our port number that's used for SIP signaling. Shows the date and time that the call was placed. Then I scroll down a little bit. It shows from SIP, this is the from address, from SIP 2000, that's my extension 2000, at the call manager, that's the call manager IP address, which is controlling the IP phone. And you see what I mean? This is so easy to understand. Shows the remote party ID right here. This is to SIP colon 1800. It's a 101 invite message. So on. I scroll down a little bit. You see the invite going through. I now received the 183 session in progress. That's the ringing right now that's taking place. And also you can see SDP messages, the session description protocol that's negotiating some of the features. Right now, and here's the session description packet that's coming up. It's saying it's using the codec G.729 for the call. And let me actually, I'm tired of hearing this thing ring. So I'm going to pick up the phone. And now you can see the OK messages that are coming through. I have OK messages that are being received. The connection is active. We now have RTP being exchanged between the two. RTP audio is engaged. Phones are communicating. I'll pick up the handset, hang up the phone. As soon as I do that, bye. You see what I mean? It's so easy. It's so easy to understand. You've got bye messages saying the call is now disconnected, a little two-way message back and forth. It's taken care of. So that's the basic configuration of SIP dial peers on the gateway and a SIP trunk on the call manager. You can also configure a Cisco gateway as a user agent. Now, that seems kind of funny because you think of a user agent as a phone. Remember the user agent client and server, the one placing and receiving the call. But here's the idea. Maybe you want your router to be almost like MGCP, where it registers its endpoints with a SIP server and is controlled by the SIP server. You know, I shouldn't say controlled. It's not controlled. It's not like MGCP in that sense, but it's going to get its lookups from the SIP server and so on. What we can do, let's say you've got this gateway, is configure it as a user agent. Whatever FXS port or POTS dial peers you configure on that gateway will automatically register with the SIP server. So it's kind of like, hey, you know, I've got extension 3000 down here. Go ahead and put that in your database. And when this guy makes calls, the gateway says, well, I'm not too sure how to get there. Let me ask the server. It's not a control thing. It's not like MGCP where it's like, I'm a dumb terminal. Please tell me what to do. It's just saying, I don't have that dial plan information. Let me refer you or send that request over to the server. So here's how you do it. You go to the voice router, get into global configuration mode, and the command is just SIP-UA. We are now a SIP user agent. And in here you can start setting up your different servers. Like I want to set up a registrar server. I want to say the registrar is going to be IPv4 colon 172.30.100.104. And maybe I've got registrar. Whoa. Oh, I was like, what just happened? I had the debug still turned on, so it's trying to go and register with the call manager server as we speak. So let me do a turn off all the debugs. So I'll hit the up arrow and do, registrar. Maybe my secondary server is 100.105, so I have a secondary server if I need to register off that. For the lookups, maybe I'm using a SIP server, to where I want to communicate with the SIP server, IPv4, 172.30. 100.104, so it's going to register its POTS dial peers with the registrar server. For any queries that I have for extensions, it's going to send it to the SIP server. And now anytime I go to a dial peer, let's say I'm creating a dial peer voice, I'll just do 555 voice over IP. Maybe I can say the destination pattern anything, meaning anything with 4-digit extension. I'm just going to send to the session target. And remember I showed you that goofy context-sensitive help before with this? Notice one of the things that you can type in there is SIP server. I can say session target's going to be SIP server. Which SIP server? That's when the router comes back and says, oh, the SIP server right here. So you can see it's not so much like the router's being controlled, and that's why I was quick to correct myself when I said control. It's not being controlled by SIP. It's just saying, you know what, if I have anything, I'll just send it over to you, SIP server, and you've got the database. You can go ahead and find it in the location server and look it up and tell me where I can find that extension. So that's the idea behind SIP and configuring a gateway as a user agent rather than directly correlating, with using the SIP protocol for signaling like we did in the dial peers. Now the last one I want to show you is a command that you've seen before. You saw it in the H323 nuggets. It's where you go in and permit call hairpinning. That's what they call it. Anytime you receive a call on a router, and it hairpins, meaning it goes through the routers into some other device. By default, hairpinning is disallowed, just like we saw for H323. I had to go in and permit incoming H323 to outgoing H323. We saw that on like the PSTN redirection. Well, in the same way, if I want to allow, let's say, a call to come into the SIP gateway, maybe from a call manager, and go out to some other SIP device, that's considered hairpinning, and it's disallowed by default, but most people want that feature. So you can go into global config mode and do voice service VoIP, and this is going back to, remember, the allow connections command. That's where we can go in and do SIP to SIP, or SIP to H323, or H323 to SIP, or H323 to H323. Allow all those hairpinnings to allow calls to come in using one protocol and either go out on the same protocol or be translated over to another protocol, like coming in as H323 and going out as SIP. This allows your gateway to truly convert between signaling protocols and also allow a relay of one coming in as SIP to another one going out as SIP. This is huge if you have, for instance, an ITSP connection. Let me clear all that off of there, to where I've got my call manager inside of my network communicating with a gateway via SIP, and then you've got your PSTN connection that is actually handled by an ITSP. Most ITSPs, if not all, support SIP connectivity. So you're going to come in as SIP on a SIP trunk to the gateway and go out as SIP to the ITSP, which allows you to reach people on the PSTN. Last thing I'll talk about is the SIP troubleshooting. Now you've already seen the debug csip messages command, and there's actually many of them that you can type in. My favorite is that messages, because it actually shows you all of the clear text messages going back and forth between the SIP server and the gateway, and all the invite, buy, ringing, all those messages that you're able to see. But there's plenty of other ones that you can do. If you are using the SIP gateway as a SIP user agent, you can see all of your active connections, like calls that are taking place right now. Typing SIP, show SIP UA connections. You can see that the service is running. It's is actually a real straightforward command. Show SIP UA service. Well, there it is. It's up. It's running. And then you can see the statistics, which is a dump of all the messages that have been sent and received. Statistics from the from the server. So you can see, how many trying messages, how many ringing messages inbound and outbound have been sent and received from the SIP user agent service. So all of that can be verified just by using those simple show SIP UA commands. But if for most of what you're doing, if you're not using the gateway as a user agent, the debug CSIP will expose just about everything. So that is the final voice signaling protocol that we are going to be discussing in this series. Hurrah! We've made it! So we walked through in this nugget SIP definition. SIP being the protocol, I believe, of the future. That's going to be the all-in-one signaling protocol for everything that we use. It'll kind of be like the TCP/IP of the voice world, but it's still on its way. It still needs to be adopted. It still needs to go through a few revision changes, get some features and some industry standards for doing some common things between vendors. We saw the reasons to use SIP, and that's to trunk to other phone systems that are using it, or if you want presence, or if you have third-party phones on your network that you want to control. We saw the SIP messages and call flow, and that's my favorite part of SIP, being that everything in SIP is clear text and easy to understand. You see like invite, ringing, informational messages, trying, very, very easy to debug and understand. And then we saw the SIP configuration, which isn't too much worse. It's not too bad at all. Using a SIP router, you can either configure it just with straight SIP signaling dial peers where it's saying, I'm going to use the SIP protocol when I signal to this destination, or you can configure it as a full user agent to say, I am essentially being controlled. I use the word again, not controlled, but registering my endpoints with a SIP server, a registrar server, and I'm doing my lookups from a SIP server, getting my information from there. I hope this has been informative for you, and I'd like to thank you for viewing.